So one thing that I fixed is this assemble rule thing. So now it works. Right. There were some minor bugs in collect rule as well. So these are the couples of modules. How do they look when they attach one to another? And these are all combinations. Another thing that I've done is that now the collect rules, for some reason, it didn't deduplicate. So if you had a rule that is identical, let me show you. Let me show you what it does now. And this is the correct behavior. So you've got a rule that says empty 0 connects to empty 3. And let's do this. So if I plug this here, yeah, it collects the rule. So if I put this rule twice in the list, then eventually it will be there only once. So it removes the duplicates. But another thing that is important is that this rule is the same thing as this rule, because it just says the same thing, just the other way around. And it deduplicates that one as well. So you're not having duplicate rules. Also, it sorts the rules, so you can have them. It sorts them. The sorting is like a logical way of sorting. First it sorts according to the source module name, then the second thing is the target module name, and then source module index, and then target module index. Anyway, the result is that you should eventually have a nicely sorted list of rules. And it basically just tells you, I'm just thinking. So everything regarding module 0 is at the beginning, and then you've got module 1 and module 10 and 11 and so on. And then also here it is sorted. So if module 0 would connect to module, here to module 9 twice, then these rules are one after another. So it's really easy to compare the lists of of rules like this, because they are nicely sorted. So that's one thing that I fixed. And I made a new feature. I was working on that this morning, and also, what is this? It's kind of strange. Now this doesn't look very correct, does it? So, because this one. Oh no, it's correct. Yeah, it makes sense, because the rule is always describing two modules, the first module and the second module. The first module is always put on the ground, on the base plane, and the second module attaches. So this is the first module, and then this one attaches. This is the first module, and then this one attaches, and so on. So once it's upwards, once it's downwards, and so on. And here we only have rules that go vertically, so that's why it always looks like this. Now, the big thing that I have right now, so the same example, the Mondier example, the one with these sticks and S shapes. So what I did here before, I identified the modules that are like front left, which is this one, and then I marked them manually, and then I marked front left like here. This is also front left up here, and so on. So I had to look at the geometry here and make decisions where should I put which rules. So eventually I ended up having this set of rules. It's 23 rules. Yeah, I have to, these are typed rules. So when I unwrap them, then I will end up having, I think, 35 rules, 36. Let's see. Yeah, it's 36 rules plus the out rules. So the outwards with outwards and so on. So what I care about is this set of rules from 0 to 35. Those are the rules that we can visualize them. Those are the rules that are describing the allowed connections between the modules. So those are these, the blue ones here, showing that, you know, this one can connect here and so on. And what I had to do to achieve that, I had to do this and a lot of manual work, selecting everything and so on. So now the new experimental feature is called suggest rules from geometry. I put it here. It's a super simple component. And the only input here would be the modules, all the modules. And let's see what is the result. Plug here. And it gives you exactly the same 36 rules. Like this.
So actually, it means that I don't need any points for connectors, and it will make automatically for me.
Yes.
Wow.
Yes. And the only thing that you need to do is you still need to specify the boundary rules, which defines the modules that can be on the surface, on the edges. You still need to define the indifferent rules, because, well, it can suggest the indifferent rules for you as well, but I don't know if that's, the workflow is quite clear here. So instead of having all this stuff here, I can plug it here and completely remove this. And the only thing I still need is the points that are marking those connectors that should be on the boundary, like here. This is something that you cannot do automatically. You need to make a decision, and you need to generate the indifferent rules. And everything else, this is just unnecessary. This is just for visualization. So this automatically detects, based on the geometry, what the rules could possibly be. And we can visualize that. So these are the modules, these are the rules, and here you go. You end up having the same rules like before. And most probably, I hope that also the solution is going to be exactly the same. I'm calculating the envelope now, and also just to give you a hint, how does it work? It detects places where, so it creates a rule where the geometry can weld together properly using the join command. If the result is joinable, then it's good. So it is joinable. If there is something that can be welded to something else, then it creates a rule. And this works for, I have only tested that for the curves, because I was doing this mainly during this lunch break. So I know it works for curves, and it should also work for open B-reps. So B-rep is a polysurface, and polysurface can be either closed or it can have naked edges. And naked edge is, for example, we can even test it now. I will just need to make this much smaller because it's becoming really, really slow. So I will make it like much smaller. Yeah, still quite slow, even in the other direction. Good. So what is a B-rep? Let me, what is that? I will show you. So if you make a pipe, out of these curves here, and the pipe here is open, this is a naked edge, because there is a surface and you can fall over the surface, and there is a naked edge. It means an edge that is not connected to any other subsurface. A sphere doesn't have naked edges, a donut doesn't have naked edges, a cube doesn't have naked edges, but if you just delete one side of a cube, there is a naked edge. So this is, let's make the radius a little bit bigger, I don't know, like 5 units, so that we see it better. So this is a B-rep, and I can use that as a geometry for the modules. And let's see if that still works. I haven't tested that. I only tested it with the curves. So no, it doesn't work. So I need to, so I need to test why doesn't it work. Also, it should work. It's going to work when I finish testing. It's going to work for B-reps and meshes. So I can do mesh pipe. Mesh pipe. This is probably coming from. Yeah, this is from Lunchbox. This is not by default in Grasshopper, but yeah. And I just need to make sure that there is an open, there is no cap. Where is the caps? None. So this is coming from a plugin, but so there is no caps. And let's see if that works. Production geometry. And no, still doesn't work. Yeah, it only identifies that this is a connection, but this one is not anymore. And I don't know really why, because they should fit, but they don't. I don't know. I need to test it, but it certainly works for curves. So if you've got a curve here as a geometry, then it works.
But you use mesh here.
Yeah, both. I tried both mesh and B-rep, and none of them worked properly. And what works now is the curves. The curves, they work. And I don't know why the mesh didn't work. I don't know. Maybe segments accuracy. Maybe if I increase or decrease accuracy, I don't know. Just no, number of segments. Let's do 4 segments. Okay, like this, and production geometry. Yeah, somewhere it does work, somewhere it doesn't. I don't know. It's probably about the rotation. It's probably about how I created the mesh. You know, it might be slightly more differently rotated here, but you see that, yeah, it creates some of the connections. It's just making some guesses, and maybe the guesses are not perfectly precise. What does it do as a result? No, it doesn't really do much. I don't know. I will keep testing. Maybe it's about the accuracy, precision. Maybe it's about something else. I don't know yet. Let me see if it's weldable. The way I made it now, maybe it's not really weldable. So I will bake and take this geometry, copy. Does it fit perfectly? It looks it does. Then I don't know why. It's funny. Let me see. Okay. Mesh join. So should have 68 vertices when it's welded. Yeah. So I've got a mistake somewhere, or maybe it's really about the precision because I'm doing a lot of crazy operations there, and maybe some of them are too much. Okay, you can keep playing with this, and when I fix the issues, I will publish. Probably I will need some precision tolerance slider here that will be a little bit more tolerant to imprecisions of the mathematics. Because right now it needs to be very, very precise. Okay. Good. Let's go to the stuff that we discussed that we are going to do. So first of all, your questions, some troubleshooting maybe, something you would like to ask? No?
Or you can just show us what you have, like share your screen and show us what you have. Each of you.
If you were playing with it, I will stop sharing mine so that you can share. Nope. Seems like nobody. Is anybody here actually? Because we can only see ourselves. Oh yeah, good.
I just
Another
don't
one.
hear you and looking you. Sorry, I'm just in iPad. I cannot follow you, but I listen you. Don't worry.
Okay.
Thank you.
Good. So you haven't been playing with it during the lunch break, right? Did I get it correctly? All right. So let's do some advanced stuff now. Or does the silence mean that everything is clear, or does it mean that you're so confused that maybe we should repeat something? So it's up to you. Should we go to advanced stuff, which only makes sense if you understand what we've been showing so far, or should we repeat something and show one more time or something like that?
Don't you want to just share your screen and show us what you have? It doesn't have to be some super cool or super complicated. Just show us what you have. No.
Sorry,
Yuri already posted something on Instagram.
Yeah,
Why don't you show? Why don't you show?
You are staying in silence. And sorry, Emil, you said something about.
No. I'm sorry. I just say I cannot. I just have a small iPad. My computer is crashed, and I am in the tent. I just only see you. Sorry, I cannot follow you. So I cannot share a screen. That's only my problem. Sorry.
That's okay. Yuri, show us, what do you have?
I can, but give me some second because it's on second computer. So it's funny. I mean, even it's not so precise. From my side, it works, and I like it. Like this. Before I will connect my second computer, someone can show what he does.
Go ahead. No, everybody is, I don't know, everybody's shy.
Everybody's so, don't be shy. Well, Maybe I should go first and then everyone see that how crazy it could be or bad. So I already have this stuff.
Okay, it doesn't look like cubes.
You know, with cubes, it was not so nice.
Okay.
And it's just one module or more?
No, it's from the morning session.
Okay.
Like we had these. And I add some more. And then I played with the seeds. And this did somehow start with curves.
Mm-hmm.
Then first result, second one, and then the last one.
All right.
Ooh. But yeah, kind of like there are components which are quite random, so it makes messy. But some of them are not so random, so there are connections. And if I will play with these more, it will be something nice.
Cool.
Yeah, it's fun.
And I just realized, why doesn't it work?
Which one?
Mine. The suggestions. Yeah.
Mhm.
Okay, I will fix it soon.
And tell us why.
It's complicated.
Okay. Oh, okay.
No, I can show you. I actually can show you because it's something that might affect you as well. But what if somebody wants to show their screen? Anybody would like to show the screen?
Like it can be really basic, just no, just share with us. It's not very complicated. Radim or Jakub.
You know, you should show something. Instead, you will be paying for this workshop.
Well, I cannot because I don't have anything. Well, I tried something, but I wasn't so satisfied with that. So I wanted to start a new one, but I was not satisfied as well. So I just decided to try it when I've got the feeling for that, and when I will know that that's the right time for making something like this.
All right.
I'm so sorry for that. I just wanted to be satisfied.
But yeah, that's the thing, because when I start to play, I saw, okay, it's maybe wasting time because I'm not so precise and maybe the result will not be so good. But I just play, whatever. I can fix it later. But I see your point. You want a precise result. That's good.
Yeah, I like this.
Okay, I will share my screen, and first of all, I will tell you why doesn't it work, and I will tell you what am I going to change, and then I will show you some really cool stuff, I hope. So the reason why it doesn't work is actually a precision problem, and the problem is that if you look at the connector planes here, like this one and this one. So this is something that you get when you deconstruct a module. It gives you the planes that are describing where the connector is and how is it rotated. And you see that this one and this one are flipped. So they are rotated. And that kind of makes sense when you think about it. Kind of makes sense, and that's why I made it this way. But it also is probably not the best decision, because the Monoceros modules, they never rotate, so you cannot really like rotate it around any axis. They are just being stuck, so they are stacked one to another. And if you want to use the planes to orient one module on another, orient is a Rhino and Grasshopper command that basically takes the source plane and the target plane, and it takes the source the geometry from the source plane and adds it to the target plane so that the planes match. And here I thought that it will be smart to like rotate it, but it's not smart. These two planes should be exactly the same. So right now there is the normal of the connector is pointing outwards from the module, but it should point the same. They both should point the same direction, because you can pick the module and copy it on the target without any rotation. Right now it's not possible because it will rotate. So so it was my bad decision to do that. And because this is like that, I also have to, when I'm doing the catalog, the one that I was fixing, that didn't work when I was showing you before the assemble. I have to rotate the geometry to actually match one to another, but that's not correct. I shouldn't be rotating the geometry. I should just pick it and place it. And I have to do the same for this suggestion of the rules. And because I have to rotate everything, there is some mathematics that is very imprecise, because you've got, in computation, you've got a limited number of floating point numbers. That's the discreteness that I was telling you in the computers. The computers are discrete even for the floating point numbers. Then when I rotate and adjust and place and copy, the precision, I lose the precision, and even though the points that I'm checking are on the same place, they are just very slightly moved one against another, and it gives me a bad result. So I should avoid all these transformations, and I will do it by not rotating these planes. And this is the reason why I told you that this might be beneficial for you as well, is that if you are going to somehow use these planes for any purpose, then you should probably know that they will be aligned exactly the same, like this one will be aligned to this one, and so on. And I think that looking at the thing, it seems like the positive ones, like the top, the front, and the left, are correctly oriented, and the negative ones are flipped, and they shouldn't be flipped. They should be oriented the same way, so that I can pick it and put the bottom on the top, and it will fit. So that's what I have to do. It's not much work, but still I have to do it and check if it fixes my problem with the precision. And then I will release a new version of this. Okay, so let's do something a little bit more exciting. And that thing is, internally I call it step solver, but I'll tell you what does it actually do. I will open a new file, and it's actually one of the example files. It's if you go to the, where is it? The problem is that whenever I switch windows, the zoom thing pops down and it hides everything that I have open. So this is the tutorial, and let's go here, for example. So you can download this one. It's called identifying more boundary layers. So I will force a specific multiple. Okay. So I'm going to open that file here as well. This one. Okay. So this example is about something else that I want to that in comparison what I want to show you right now, but this is a good example to show you that. So let me guide you through. Let me go through the example. So first of all, I'm creating some slots here. These are all the slots. There is some shape that I converted into the slots. They look like this. This is a two-dimensional example. So, well, it doesn't really look like two-dimensional, but it is. And I do a couple of things here, and I can maybe tell you what do I do. So I have populated a world that looks like this with slots. What I want to do is I want to identify, eventually, I want to have something like this that is two-dimensional, and I want to place, as a result, I want to place different shapes in the outer layer, different shape in the layer a little bit deeper, and different shapes in the rest of the thing. So there is also if you look at the modules, which is this, so you will see that the modules, let me show you like this. So these are the modules, and some of them are the sharp ones, some of them are the orthogonal ones, and some of them are the round ones. So I have the sharp ones on the outer layer, the rectangular ones here, and the round ones inside. So first I have all the slots here, and they are three-dimensional. What I do is I use the rslots boundary component that basically tells me true, false, and I can dispatch. Dispatching means dividing a list into two streams, two different lists. One is, if you look at the pattern here, then it goes, there's a lot of true, false values. I will tell you how many, 5,000 something. There is exactly 5,000 something slots. And if this value is true, then the first slot goes to A. If a value is false, like for example here, 2,123 is false, then slot number 2,100 and so on goes to B. So it basically gives me, as a result, in the slot A, it gives me all the boundary slots that are outside of the envelope. And on the B, everything else, it means the slots that are inside. So this is the difference. The outer slots and the inner slots. Here I can define how many outer slots. So I want to take two layers. But this works in 3 dimensions. If I started with something that is 2-dimensional, just like the result here is 2-dimensional, that wouldn't help me because everything is boundary here, because there is nothing above and nothing below. So I need to have some volume so that I can take 2 layers from everywhere. So I take away these 2 layers, and this is what remains. From what remained here, I do the same thing again and peel off 2 layers. What remains is 1 layer inside. So this is the innermost layer. And in this layer, I'm going to allow these slots, these allow placement of Okay, I simplified things here a little bit. So I've got the slots that are the innermost. Then I should deconstruct the slots like this and use the center points of these slots to generate new slots on their place. And I will specify exactly which, oh wait, no, this is not ready to be shown like this. So on their original positions, I will create new slots, but these slots are going to allow placement of only certain modules. And those modules are the round ones, these. So I will recreate the slots there with only these slots, these modules allowed. So instead of having something that allows everything, I only allow specific modules. I do the same thing here because in Grasshopper, there is something called automatic casting or typecasting. It means that when you have data of certain type, it automatically can cast to different data type. A good example is, for example, a plane. So this is a plane, but I can also cast the plane into a point. So I can convert it into a point, and then it takes the origin of the plane and gives me a point. You can do the same for many things. You can cast a point into a vector, for example. So this is going to be a vector now, even though it looks the same, but it was a point and it's not a point anymore. It's a vector. Or you can cast, I don't know, the length of the vector. So we can have like unit x vector that looks like this. If you cast it to a number, it tells you the length of the vector, which is, in this case, it's 1. So there are many automatic casts in Grasshopper, and this is what also Monoceros does. So the slot can be automatically cast to a point, which will extract the central point from there. So I can take a slot and use the slot as a point, as a central point for a new slot. So I don't have to deconstruct it at all. The same applies for modules. The modules, they can convert to many other data types as well. I don't think that the modules actually can be converted to points, no. But they can be converted to, for example, this is kind of useful. They can be converted to module names. So I've got modules here. This is full of modules. And it can be automatically converted to module names, which allows me to specify, so these are the module names. So when I'm creating a new slot, I can use old slots as central points, and the actual modules as module names allowed to be placed in those slots, because it automatically casts. So what I'm doing is here, I'm creating new slots that only allow placement of the round modules. I'm also, another thing that I can do is if I want to see exactly how many slots am I how many modules am I allowing to be placed in a slot, if I want a visual aid, I can also insert a list of all modules available in the solution, and it takes a while now because it's calculating, but it gives me this in color. It's very gray because it allows just quite a lot, quite a few. I don't know. I should switch to some different view. No. Yeah, shaded. Okay, that worked. I can use shaded. So now they are almost black because they only allow a couple of modules to be placed. So this is how I recreated the central, the core of, yeah, this is the core. And here I'm allowing only the round ones. Then let's have a look back. I have identified the core. Where am I? Here. So this is the inner. Yeah, this is not visible. So this is the inner layer. I peeled off 2 layers, then I peeled off 2 more layers, and what remained was this. Here, this is the 2 more layers around the core layer. And here I'm only interested in vertically in the same, like in this layer, vertical layer, because I only want to place things in one layer. So what I'm doing here is I'm taking this peel that I took from there, and here later on I'm checking the Z position and only picking those that that are on the Z position here, and I do that for all of them. So basically from all the slots here, I'm only taking the central layer. But before, what I do before, this is the peel around the core, and I'm defining that this peel can contain another set of modules. So again, this is a different set of modules. I can display that in a color. Coincidentally, this is 5, 7. This allows 7. This allows, again, 7, but different 7. And the outermost layer, which is this one, also allows 7. So it gives me the same color, but now I have a selection of slots that are very specifically allowing certain certain modules to be placed in them. I will change it a little bit so that you can actually see better what does it mean. But I just want to show you the result of this. So when it calculates, it takes a while, and it also requires a couple of attempts. Let's wait a bit. Okay, 13 seconds. I will look at the report, and then I will tell you how to read the report. So this required almost 4,500, 4,350 attempts to solve. So it is a very hard setup, and it was very hard to solve, but eventually this is the result. So the 2 outermost layers, they contain only the sharp parts and so on. So this is maybe a little bit too complicated how I created this, but this is how I did. Let's make this thing a little bit more benevolent, by which I mean that the outermost layer will still only contain the sharp shape. The layer underneath can contain either the sharp or the rectangular one, and the inner part will contain will still be able to contain anything. So let's start with the inner part. Now I will specify, I will disable this because it will be slow. So instead of just allowing the round ones, I will allow also the rectangular ones and the sharp ones. And the layer above, I will allow not only the rectangular ones, but also the sharp ones. And I will keep the outer layer as it is. And as a result, this might be even visible in the original setup. You see that now it's got different colors. This is very dark outside here because it only allows 7 placement of 7 modules. This one is slightly lighter because it allows placement of 14 modules, and the core layer allows placement of 21 modules. So it's completely white because it's 21 is all the modules that are available. So if I run the solver now, let's see what we get. I believe that it solves much faster, and it did. And now you see that because the sharp ones are allowed also in the layers, not only the 2 outer layers, then it could actually continue also inside, and it creates different results. And if I don't like this result, for example, there is no round shape. So I can change the random seed. And this only requires 24 attempts to solve, so it's also very fast. So I will change the random seed, and yeah, and I already have also the round shapes here. So this is how I play with the thing. And now I want to show you, this is still not what I wanted to show you, but this is a good beginning. So is there anything you would like to discuss at this point?
If I understand correctly, so then you are able to really set for certain position of the slots.
Exactly.
Specific modules.
Yes.
And you are showing this now. We see it in kind of 2D, but it also works in 3D, right?
Absolutely, everything works in 3D. And you see how difficult it was for me to switch from 3D to 2D. It's much easier to work in 3D in Monoceros, but also it's more difficult to show examples in 3D. So that's why I'm showing you in 2D. And the first question, yes, you can specify very specifically, I want to place this module in this location. And the way you do it, if you have modules that are larger, that have more than one part, then you can, an easier thing would be to select one of the slots. So I've got a collection of slots here, and I will say, okay, slot number, I don't know, 254. So I will pick it, item, this one. So it's randomly, I picked this one, and I will say this one will be able to contain only, I don't know what are the module names here. So I will just select one of the modules. So one of the, this is a collection of all modules, and I will say number 15, whichever it is. So let's have a look. It's going to be, no, this is not, let's do something that we can distinguish easily. So, no. Yeah, this round one, so number 18. So here, and also let's have a look if this would work in the setup. No, I need to pick a better module, a white one, to be sure. Okay, so this is a white module. This is the one that I picked. This one. So I will say that this one must. Okay, this wouldn't work either. Let's. I will tell you why this wouldn't work, but just give me a moment to set things up. Okay. No. I want to use a very sharp one. Yeah, okay, this one. I'm going to place this one in that slot. So, like this, I've got the slot. It's this one. I will deconstruct it like this. And I will construct a new one instead at the same position with the same base plane, with the same diagonal. And this is the module name that I'm allowing. So it's green. No, it's blue. But let's do it like this. If I provide all the modules, it becomes green. So it means that it's already solved. So it's clear what it can contain. And then I will create a new. So it only can contain this this sharp shape pointing this direction. So this is what we expect there to appear eventually. And I'm going to replace the original slot with this one. And that I do with cal index. So I will cal index with the same slider gives me everything except that one slot that I took out. So this is everything except that one. So I merge it, everything plus the new one. So now I have, I don't know if you can see it in Zoom, but right now here I've got one green module, one green slot. This means that this position is fixed, and that can only contain that one little, it looks like a beak. So And then I use these slots for the solver and hope that it finds a solution. And let's see if that actually worked. So this is the slot, and it really does contain that one module.
Mm-hmm.
And everything else is built around it. So even if I change the random seed, you see that this is something that doesn't change because nothing else was allowed to be there. The thing is that it is kind of risky because you may end up placing a module somewhere where it's impossible to find suitable neighbors. Let me show you what I mean. If I do that.
But actually, I have a question. For example, in really practical way, if I know that I need staircase, for example, in certain position, I can pick like 4 modules, say this will be staircase, and then I generate rest.
Yes.
Cool.
Yes, this is the purpose.
Cool. Because that was the thing, right? The solver pick the one and then propose the solution, and then instead of random picking, I say, okay, this is the certain position.
Yes, but you need to be careful. Now I'm going to do something that that will be not solvable, and maybe you can try to think about why. So
it's Friday.
Yeah. So this is the module that I'm going to place, this round one. This is, so remember the round one, and I'm placing it here. And I really believe that this will never find a solution. Yeah. It's not even trying. Do you know why?
Doesn't like rounded.
Because you before specified that the rounded one can be only inside the structure and not on the outside layer.
That's the beginning of the answer. That's correct. And what is the rest of the answer? Because right now I said this has to be here. So anything else that I said, yeah.
It's not the white module.
That's okay, because this is overriding anything that I said before. Now I said this is going to be here, and that's true. This will be here. Even if I look at the materialize, it is there. But what the problem is?
It cannot close itself.
Exactly, because the neighbor is not allowed to contain any allowed neighbor of this round one. So the round ones can be only in the white part, and this one requires a round one as a neighbor, and it's not allowed here. The neighbor cannot be round. And another thing, this is also on the boundary, and you cannot have, like this cannot be on the boundary because it's not allowed by the rules. So you can place things manually, but you have to be incredibly careful while doing that, because then you might end up with something that is unsolvable. And this is super easy to happen. Like this can happen anytime. So yeah, but thank you for the answer. It was correct. You got it right. I'm very happy that things are clear. Iri, is it clear why this is not possible? Okay, and this is super risky, and I'm just now not doing that thing anymore. Like I'm not placing something specific into a specific location, but let's do something else instead. And this is something that I find, like this is probably the most powerful thing about Monoceros. Well, beyond that, it's wave function collapse. What I'm going to show you now is like super exciting. And I don't know, I haven't used it yet because it's such a new thing that I haven't really tested in practice, but I'm going to show you anyway. So so let's see what we have here. We have a solver. Let's read what we have here. The Monoceros wave function collapse solver found a solution. That's good. We've got a solution. The rule count and the part count, that's quite a lot of rules, quite a lot of parts. And the slot count, including the outer slots, that means the big overall envelope is quite a lot. So, and this required 8 attempts to solve. Now, solver observations limited to a really large number, and I will come back to this. This is why I'm showing you. And this is an interesting thing. We've got a lot of slots here, but only 412 observations were needed. And if you remember what the observation is, it's the moment when you decide, when the solver randomly picks one slot and randomly picks one of the modules that is going to be placed into that slot. This is what I actually did here manually. I made an observation here. And I made a really bad one because it prevented everything from finding the solution. And that can also happen to the solver. Mine was really dumb because I placed something that originally wasn't allowed to be placed there. The solver doesn't make such a mistake, but it makes the observation is a moment when the solver decides this is going to be placed here, and maybe many steps later it finds out that this was not a good choice, and it doesn't even know which bad choice it was. It just creates a contradictory solution, and it has to try again. And in this case, it had to try 8 times. So that's the number of attempts. So when it made a decision, it propagated the change and cleaned the world so that only the allowed neighborhoods were possible. And then some of the slots still could contain more than one module, and then it had to observe again. And this had to happen 412 times. It had a lot of bad attempts, and in general, it stopped after 341 observations in average. So the average number of attempts until something failed or finished was 341. But what is happening inside? First of all, it cleans the world so that only the allowed neighbors can, only those neighbors that are allowed by the rules can be placed in the slot, even though it's more than one. Then it makes an observation and again cleans the world so that only allowed neighbors can be placed, and so on and so on and so on. So this is observe and clean, observe and clean, observe and clean. Now, there are 2 more inputs here. I don't know if I talked about this one. This is not so interesting. This is just a different algorithm. Sometimes when it cannot find the solution, maybe you can switch to the different algorithm. I'm not going to talk about that thing. But what is interesting is this. This is the maximum number of observations. This is very similar to the maximum number of attempts. Here, if I say the maximum number of attempts would be 5, this would fail because 5 was not enough to find the solution. If I say 10, this will succeed because it needed 8. It also needed, the attempt number 8 needed 412 observations to find the solution. I can limit the number of observations. By default, it's set to almost infinite. So if you don't change anything, it makes all the observations until it either finds a solution or fails. I can limit the number of observations. And if I say I want to limit it to 200, then the solver will stop before it finds a solution. So it gives me an orange thing. It tells me that the current solution is partial and the complete valid solution is not guaranteed, because after these 200 observations, it could possibly make some sort of a mistake and fail. And in fact, it certainly does, because it only made one attempt. So this is what we see, what happens after 200 observations in attempt 1. But still, it gives us some output result. And I'm going to hide this and only leave this as a visible thing. And this is a nice thing, nice visualization. So the solver returns new slots that are already somehow processed. And the green ones, they are settled. Those are the ones that already know what should they contain. The white ones can still contain everything. And the black ones, they are almost solved. But we stopped the solution at 200 observations. If I keep increasing, you see that now this is solving more and more and more. At a certain point, it fails and tries another attempt. So I will decrease the number of attempts to 1 so that we can actually see the problem. So we only have 1 attempt. The solver is limited to 238 observations, but it only took 328 observations. And at that point, something wrong happened. And one of the slots is now contradictory. And we can have a look. It's this one. It's red. And this slot is not allowed to contain anything because it, like, the world cleaning was coming from here. This was okay. And this requires, as a neighbor, something that is not allowed by this one, and this one. So the problem happened here. And this is not that we are going to solve the problem, but I just want to show you that you can show partial results. This is not so useful just to show the partial results, but it's very useful for something else. If I set the number of observations to 0, so no observation made, then let me show you what happens. If I show this, this is the world state, the slots that I created manually. And you see that they have certain colors. It's white inside because everything is allowed. Then it's a little bit darker on the outer layer, and it's very dark on the outermost layer. It's so dark that you cannot see it in zoom. It's actually somehow gray. But if I run the solver with no observation made, it only cleans up the world. So all the slots only contain modules that are allowed by the neighborhood rules without making any decision. And you see that it is already different. So now this is almost black, which means this one can contain less modules than, for example, the one next to it, because that one is slightly lighter, and this one is even lighter, and it can contain more, and this one can contain even more, and so on. So it already did something. It cleaned the world. And this is super interesting because we can make the observations manually now, which means that we can decide based on some logical thing what will be placed where. And by logical thing, I mean you can make informed decision, because the solver works more or less randomly, and the only thing that is given is the rule set. But there are certain things that you cannot specify with a rule set. Like, for example, if you're designing a city, then you want to place a residential house, and you want to make sure that there is going to be a park within 5 blocks, in diameter of 5 blocks. This is something that you cannot define with a wave function collapse rules or Monoceros rules, because you only can define what is an immediate neighbor. But you can stop the solver like this, have a look, check the slots that can contain the residential house, check whether there is a park nearby. If there is a park, you keep it there. If there is no park, you will manually remove that option from that slot and run the solver again and again and again. And you can make different decisions, different informed decisions manually, and they can be basically anything. It could be, you can check whether there is enough staircases in the house or not too many, or maybe you are building up something from colorful sticks, and you know that you only have 5 blue sticks, but 200 red sticks. So when you run out of those 5 blue sticks, then you remove the possibility of placing a blue stick from all the undecided slots and only keep placing the red sticks. So let's make an observation manually. And this is where this becomes a truly architectural tool. But also there is a huge risk that you will not find a solution at all. Yeah. But anyway, let's do it. Let's do it. So right now we have a world that is cleaned up, and I will now randomly pick one slot, list item. So I will pick one of the slots here. I'm picking randomly because I don't know. Yeah, I'm picking randomly. 250, which is this one. It looks okay. So I will cal index like this. So I've got this one, and I can deconstruct this one, and see what the module names, allowed module names are there, and I can make a decision. Maybe I will say that, maybe I can make an observation, which means I will pick one of the modules that are allowed, only one of many. So I will say number 3 will be allowed, whatever that is. I don't know what that is, but it's what is the name of that? It's called 2. So let's see which one it is. So if I look at the names, so it's going to be this one. So I can say, okay, this one has to be there, but I will do it only afterwards, a little bit later. And then I will reconstruct the slot like this. And this is the one that is going to be allowed there. And now I will merge this and this. And with a new setting, I can run another solver. So I will place another solver here. I've got new slots now. The modules, they remain the same. So I will just, you know what, the easiest way would be just to copy paste it. And instead of the old slots, I will plug in the new slots. And now I've got, I should have a different solution. Now you see that this one is already decided, and it cleaned up the surroundings. So this is what, okay, let me show you like this. These are the slots that were at the beginning. Now the first cleanup, then I made a decision, second cleanup, and you see that things have changed here. And then I can make another decision and clean up, and another decision and clean up. Or maybe I know that it's good now and I can allow more observations. So this even gives me something that is already decided. And I can keep, maybe, no, there is a contradiction. I can increase the number of attempts, and it eventually found the solution. The good thing is that you can combine this with other Grasshopper plugins, like, for example, Anemone, which is a looping plugin. And this is something, if you don't know Anemone, then just disregard this, but I will just show you what does it actually do. So let's do it like this. I will repeat the same thing over and over again. I will, after each cleanup, I will randomly pick one slot and make an observation there. This is what is happening internally, but here I have a better control, and I can make a better informed decision. So if you don't know how Anemone works, then yeah, refer to the tutorials that Iri will give you, or ArcSafe gives you. I'm explaining it there, but for those of you who know, I will just loop the slots. I will make I will randomly pick one slot to observe, and then what's wrong? Oh yeah, like this. So I made a new setup. This one is decided now. Yeah. And I've got a new collection of slots, and I will place it here. And this can be repeated over and over again. Let's do another thing. Yeah, I will use the same random here to pick the one slot. It doesn't really matter. But basically what am I doing is I'm manually making observations and cleanup and observation and cleanup. And I will do this, let's say 1000 times, or in other words, until the world is okay. If I find the solution, then stop the loop and then do the materialization thing. So materialize slots like this. And these are modules. And maybe we can see how this is eventually being solved, like this and this. So I will keep these visible. And let's repeat 1000 times. So I'm making random observations, and there is a high risk that this will fail somehow, but maybe not. Maybe we will achieve something. Okay, now we already have a contradiction and it keeps going, but it's useless. So you shouldn't be just randomly picking, like I'm doing it just without any thinking, because you see that this is not a good approach. But you can occasionally stop, look, make some sort of decision, some sort of a cleanup, and then continue with more and more wave function collapse. Instead of maybe making a real observation, like picking one of the possibilities, maybe we can remove one of the possibilities randomly. So we, like, with these examples, I'm not really able to make it more meaningful, but let's try. Let's try to change it a little bit. So what we can do here, we can increase the number of attempts. That's another thing that we can do. It probably would help. So no, because with the 0 observations, there is no, the number of attempts doesn't do anything. So, but I will set it to 10 anyway. But instead of picking 1, I will just remove 1. So instead of one option from a slot, so I'll do cal index. So if this, I will remove 1 from the possibilities. And if this is, I can only do this if this is empty. So if this is, I cannot make an empty slot. So I need to check whether this is larger than 0. Then if the number of allowed modules is larger than 0, if it's still larger than 0, then it's fine. Otherwise, I need to use the original one without removing anything. So there is a stream filter component. So if this is larger than 0 after removal, then good, use that one. If it's 0, then use the original one and don't remove anything. So now instead of picking just 1, I just remove one of the options. And let's see what happens here. So it's really slowly doing something. And you see that they are getting darker and darker. And maybe we can allow the solver to make exactly 1 observation per turn, or maybe even more than 1. And let's see what happens here. So it usually just picks an empty module. No, it already picked some meaningful modules. But this thing that you limit the number of observations means that you basically interrupt the solver and do something manually instead of the solver, and that something could be something that is informed and meaningful and less random than the original solver. And I believe that this eventually will find some solution so that it doesn't really end with a contradiction. But it also brings the responsibility to handle the possible contradictions, because it is being handled by the solver by increasing the number of attempts. But here we would have to do it manually. And this way you can, I think I can imagine how this could be useful for urban planning, but you see, we found a solution. And I can really imagine this would be good for the situations like I explained. When you want to look at the broader picture and make a decision, like there should be something close to something else, but not really immediately, but somewhere farther away. That's one option. Another option is that you want to make sure that, I don't know, the distribution is even, so that you don't, when you're planning a city, you don't put too many factories or all the parks in one district and no parks anywhere else. Or you can check whether the staircase is close enough to another staircase, or you check whether if you are not running out of certain modules, because you've got a limited number of modules, and then you can manually make some sort of decision. And this is how you do it. You basically interrupt the solver and do something about the current situation manually. I will restart. I'm quite curious if this would work with 0 observations, which means I will just keep removing options, leaving 1, and maybe this will find the solution, but it will take time. It will be really slow. Maybe I will need more than 1,000 repetitions. Let's make more than 1,000. And maybe it will end up with a contradiction, which is something that right now we cannot resolve, because it is happening internally in the wave function collapse solver. Yeah, but basically this is it. I didn't want to show you anything more. Maybe for I don't know. I think Jiří has another phone call. Do you? Yeah. So yeah. I just wanted to wrap things up here. I will give you space to ask questions, but the idea here is that now you should have most of the tools available, and with the tools you should be able to start experimenting yourself. And as far as I know, we are going to make another tutorial session. I don't know when Jiří is going to announce.
Yeah.
In that session, I'm going to show you, or we are going to show you, how to evaluate the results and how to make something that is a little bit more meaningful. And then you will have still some time to work on that. And I think we can make some critiques for you. Maybe we can invite somebody to have a look at what you've done and give you some feedback if that's interesting for you. For the people from UMPROM, this is an extra thing. This is not part of your curriculum at UMPROM. You can, but you don't have to take part in this. Take it, consider it as an extra workshop that you are taking apart from the main compulsory stuff at UMPROM. I don't know how is it at Jiří Vítek studio, cluster Uran research.
Yeah.
Thing. I don't
Research cluster Uran thing.
Yeah.
Yeah. Okay. Maybe like this. We really would like to kind of push you into really go into this instrument and really focus on designing things, not just like playing, but really try as much as you can, because in next step, the thing is in this week or next week, you should start to really go back to these 4 tutorials, set kind of simple components, try how it works, design your first kind of system, and then we really would like to also provide you some kind of context, and then you can start play as a kind of residential project in certain context, and really try to also push the tool as far as you can, because it's not only that you learn new stuff, but also it could be nice feedback into the Monoceros system, right? right? And then the thing is like next week, let's say on Friday, we should have kind of review with Q&A. Then we will solve what kind of problem you had and what kind of system you have and how you can go further. And in this time, I will show you the context and I will give you all the data, what you needed. And you should start to play on the context to build your project. In 2 weeks, we will have a workshop with Jan with these analytical tools and advanced technique. And then in the end of the March, we should go through all your project and really look what you have done and invite some people and talk about it.
If that is the case, then I think that also the people from Umprum will already have, because we split the semester into 4 parts, and I'm teaching the second part of the semester. You can, but you don't have to use Monoceros for my part. I will encourage you to do so, but you don't have to. But if you do, then you can also join the reviews, the final reviews of this workshop with the project that you have at Umprum. So you don't have to do an extra project.
Mhm.
But again, this is I don't know. Is it compulsory for your students? Is this part of their studio?
Yes, it is. We have kind of topic about Villatugenat, and we are thinking about the parts of Villatugenat and how we can assemble them in different way and how we can actually generate kind of new Villatugenat in new context.
So for the people from Umprum, this is not compulsory. So if you don't take part, it's not going to be a problem. But I would be very, very happy if you do participate. Okay.
So it's done for today.
I think.
Questions?
Well, I think we should open this for questions.
Sure.
And troubleshooting and all these things.
But I guess that probably everyone was just looking now.
Yeah. No, but
So
maybe there.
Yeah. Mm-hmm.
Maybe a question if I can look for these things in the FAQ on the Monoceros site also.
No, this is new, and this was done after the
Okay.
So this is new, and also I kind of have to figure out how to use it properly. But you don't have to use it. This is something extra. If you unplug this, then it works just like before.
Mm.
But you can play with it somehow on your own. And also there is another thing in the documentation. I did my best. I tried to make the documentation informative, but at a certain point I realized that I don't know where to stop, because there's so many things that I can keep saying and trying and explaining, and this is a whole new world of possibilities, and that means that probably the documentation will be 3 times as long as it is now. And I don't know. I wish somebody reads it, because I spent a lot of time writing it, but then I realized that maybe making a workshop is a better idea. And this is already quite a long workshop, and you see that we are barely covering all the possibilities here. So maybe making a longer ongoing workshop for these advanced things is a better idea than writing the documentation. FAQ.
Jan?
Yeah.
Can you share these files with us, or?
Yeah, I think I did. I will save this one. I don't know if this one is really like working well, but I will send you. This is going to be. Yeah, I will save it and send it to you.
Cool. Thanks.
Okay. My question would be, so if I will be thinking about kind of tectonic optimization or consideration or solar analysis with this kind of end up of the script, I am able to solve it.
Yeah, you have to think about it like you will get some intermediate results, and you need to look at those results, make some sort of evaluation. This is something that we will do in the following part of this workshop 2 weeks from now. You will somehow need to look at it and make some sort of evaluation. And this is difficult to, I don't know what the evaluation would be, because that's very specific to each project. And when you make the evaluation, then you can make some sort of decision. So you change something, you keep adding possibilities. You can even add or remove slots. Maybe you can change the envelope, and let the wave function collapse do the heavy lifting for you, like organize things properly, and then you have a look again and reorganize stuff and so on. So if you want to make some tectonic analysis, of course you can. If you want to make some just aesthetical decision, you can. If you want to measure economical aspects, you can. So whatever works for you. Yeah.
Okay, cool.
Somebody's asking, let me read it. My microphone doesn't work, but I really enjoyed both days with you guys. I'm really into the plugin, and I will try to learn how to use it and make my own solver. Thanks once again to you all. That was not a question, but I really like the comment, and you're welcome.
Happy to hear it.
Iri, I posted
just to make own solver.
Solution or setup.
I know.
Iri, I posted the exercise 5 into the chat, and you put it wherever it's you. Okay, so this ended with a contradiction. So yeah, this doesn't have any solution. So I don't know where the red one is, but there must be one here. I don't see it now. Yeah, it's contradictory. So I don't know. It's probably this one. I don't know. Anyway, so as I told you, this is kind of a risky ground, and you need to be careful walking on it. But it's still safe to use it as we did before. So yeah. Cool. Anything else? Anyone would like to say or ask or whatever? I'm switching off the Rhino. Get Rhino 7. It's on sale until the 10th of March, which is just a couple of days. And you need to have a confirmation from the university that you're a student, and it's really cheap now. We still haven't done that. We have to do it.
Maybe I have a question. I think I will have to share the screen.
Yeah.
Because I tried the one from the basic stuff that is on the Monoceros site, and I have problem that the curves are not only in the envelope. So maybe if you can tell me what to do to have them only inside of the envelope.
Can we have a look at how you? Well, I will request remote control. May I?
Yeah, sure.
Okay. So if we look here, so you've got, what is your geometry? You've got 4 geometries. You've got 4 module names, and you've got 4 modules.
Yes.
Okay. I believe that the order in which you were referencing the geometry is different than the order in which you were referencing the points.
That's maybe it, because I had
I
the
will
problem. Yeah, sorry.
I will explain why this is happening, because the first point indicates where the module is, and the first geometry is placed into the first module, and it's being placed along with the cage. So if this is your first module, and let's say this is your first geometry, then it picks up this thing and places it somewhere, and it takes the module along. So yeah, you need to select them in the same order.
Yeah, yeah. Okay.
I don't know how to give up remote control. I'm giving up.
Thanks.
Anything else? Anyone else?
Can I have a question?
Absolutely.
I don't know if you already answered the question, but is there a way to limit the vertical stacking of the modules or slots? So, if I understand correctly, you can specify the slots. You can pick these slots themselves, but can you limit the height of these slots? Like, you can limit the slot one can stack only a few times, and then it cannot stack on itself again.
So you're probably speaking about modules, not slots.
Yeah.
I'm looking for a simple answer. No, the simple answer is no, you cannot do that. But there are ways how to do that. So you can, for example, if you want to allow something to be stuck maximum 4 times, so 4 same modules above each other, then one option would be interrupting the solver, looking at the current state. If 4 modules of that type are already stuck one on top of another, then remove the possibility from the slots above. This is a complicated way how to do that, but it's quite a good one. Another option is if sometimes it's feasible to do it this way. So you can have either 1 or 2 or 3 or 4. Then instead of having the module just once, you will create a version with 1, a version with 2, a version with 3, and a version with 4. So you've got 4 different modules. And what you do is you don't allow these to be stuck on top of another, and also mutually. So the one with one part cannot be stuck on itself, neither on itself, neither on the one with 2, neither on the one with 3, neither on the one with 4. But it can be a neighbor with something else. And this way, you will just basically put either 1 height, 2 heights, 3 heights, or 4 heights immediately at one time, and you are sure that nothing visually similar is above or below. And this is an easy way how to do it. If this is a feasible thing for you, then this is an easy way.
Yeah. Thank you.
You're welcome. Nice library behind you.
It's just background.
I know.
But yeah, thanks. I try to match the lights as well.
Awesome. All right. Anyone else? Anything else?
So then,
okay.
Okay, thank you all. Thank you, Jan, for amazing
Thank you for the attention
workshop, and let's work. Really, it's fascinating. I got so many ideas. So let's try it.
Let's fight it.
Not fight, just relax. I mean, there is so good documentation.
I know, it's awesome.
So you can't be lost.
it's
Yeah,
very
it was
powerful.
really amazing.
We are happy, right?
So,
Christina, was it nice for you?
Read it, all of it.
No, the workshop.
Yeah, workshop. Yeah, it was one of my first workshops, but I hope that you learned something from me. I tried. And it was also useful for me because, before you teach something, you have to learn it. So it was workshop also for me, so I'm glad.
Yeah, I was very bad at you checking whether you've read the documentation or not, right? Asking you every single day.
Yeah, that's right. You already asked.
Yeah. All right then. Let's wrap it up.
Cool. See you.
Have a nice evening.
Yeah.
And see you quite soon, actually.
Yeah.
Oh, thank you.
Thank you. Bye-bye.
Thank you very much. Yes.
Bye bye.
Bye-bye.
Thank you.
Thank you very much.
Bye-bye.
Thank you.